Alrighty guys, welcome to the video. Today in this video, what I wanted to do is I wanted to give a fully comprehensive system responsiveness and mouse input lag guide. And the reason why I wanted to make this video is because there are a lot of videos online that tend to cover one part of the actual system chain, but they don't actually kind of cover all of the topics in general. They tend to only take one specific part, and they sometimes don't actually work very well, especially if you don't actually understand a lot of the other processes that are running underneath that. And so this video essentially is going to be going over all of the different things that actually are what are controlling your mouse input lag and how we can manipulate them to work better. And I'm going to be explaining all of them to you. And so this is going to be a super quick video. And that's my goal, is essentially to educate you guys on all of the different things that are happening, what we can do about it, and how that actually affects the system. I will go over which ones are my favorites as well, so that way you guys can kind of figure out which ones are like the best to go after first. And so the first one I want to go over is Csrss.exe. Csrss essentially controls the Windows 10 input lag thread. And so it essentially controls the thread that's responsible for taking the information from your mouse. And the way that you can verify this is if you move your mouse, you'll notice that CSSRS is always going to be active on the IO delta, or the input output delta. As soon as you stop moving your mouse, CSRSS stops working. And so what we want to do is we want to set this process to the highest priority in Windows, because the reason why is because if this process is the highest priority, then it means that our mouse responsiveness is going to be the highest priority that Windows can focus on. And the way that we can manipulate this service is the way that we can do it is if we go into this performance option right here with the image file execution options, and we create a key called CSRSS and a key within there called perf options. We can create two different DWORD 32-bit values. And what they do is if we name them CPU priority class and IO priority, we can specify it to run in real time. And we can also specify the IO priority to high. And so it doesn't say it right here because Windows doesn't like reveal that information through Proceess Lasso or any other service. And so we just know that it is functioning because we can change it in this service right here. And so that's the first thing. And that's the one that I find that most people tend to have the best success with. Now that we've finally manipulated that specific service, there are a lot of different buffers that happen in Windows. And one of those buffers is essentially the mouse data queue size buffer. And what this does is it essentially controls the amount of time Windows waits for a amount of information to be stored in a sort of data queue. And so what it essentially says is, this is the amount of information I'm willing to take in before I send it straight through the system in order to be dealt with by other processes in the system. And the reason why this one is really important is because this process is set default to 100 as a default value. And if we want to manipulate it, we can set this value to as low as 20. And we can set it technically lower. The problem is that if we set the data queue size too low, Windows will bug out with the mouse, and you'll notice that you start to skip sort of mouse movements. And so if you set this too low, you're cutting off too much of the mouse data, and then you're not allowing all of the data to actually get fully sent through. And so the lowest value I've found is functional is about 20. You can technically go lower, but if you set it anything below, especially 10, yeah, you'll definitely start to notice a bunch of problems. And if you set it to 1, your mouse starts basically skipping all over the place and starts doing a bunch of really weird things, because this is controlling that actual service that is responsible for that very specific buffer that's taking place right here, where it has to essentially take the cutoff for that and then send it to the next process. And so now that we've tweaked that, once we name that and we set everything there, you will have to restart your system for just about all of these tweaks, but you should try them all at one at a time, because some of these changes can be really dramatic in terms of how much they affect your system. And so the next part of the system chain is a thing called an interrupt. And an interrupt essentially says, hey, I want this process to be done next in the chain, or done right now, rather than the next part. So essentially what Windows says is, okay, I'm going to do this service and I'm going to take it all the way to the very end. But sometimes certain processes are going to be of a higher priority. And so an interrupt is what that does, is it essentially prioritizes whatever the interrupt is saying to do. And so this usually can be very beneficial if you're doing something like your mouse, because your mouse is something that needs a lot of interrupts because it's a very sensitive interrupt process. If Windows chooses to interrupt a different process, then we're going to have issues with conflicting interrupts, and that won't help you. So the way that we can specify an interrupt is if we go into Device Manager and we go Devices by Connection, what we can see is that we'll find a bunch of different device managers, and this one especially is the device USB hub. And a lot of people online will tell you to set this one specifically to an interrupt. You don't want to do that, because if you set the interrupt to the USB controller hub, all of the interrupts that are running on your system for these different input devices, like your headset, your keyboard, your mouse, all of these different things will essentially all be interrupting at the same time. And you don't want that. You only want to specify interrupts for very sensitive things like either audio or your mouse. Basically nothing more, nothing less. Those are about the only two that really should be using interrupts, or your GPU. And so if I go into here and I go to Properties, this is the mouse that's specifically for me. This is the one that I use. It'll have a device physical object named of 59. If I go into the Interrupt Affinity Policy Configuration tool, I can see that I have device 59. And what I want to do is I ideally want to put my interrupt on a core, a singular core, and I want that core to be the least busy. And so that usually almost always is not going to be core 0. So if you only have a 4-core system, you can put it on the other 3, just don't put it on core 0. There's a reason why a lot of people talk about this one online. It's because all of the other interrupts happen on core 0. So that's why core 0 is always the most problematic whenever you're running certain systems. And so for me, core 6 is the least busy in the system in terms of what I've analyzed from different software. And so now that we've specified the mouse, we want to specify our GPU. The reason why is because if we can specify our GPU on the same core that our mouse is also interrupting, it means that Windows doesn't have to jump between different cores for interrupts. So essentially it doesn't have to go to this core and then back to this core and then try to manage them and then go straight forward with the process. It can run both interrupts at the same time, and then it can go onto the actual system. And so that's why this is really important to tweak correctly. And so you want to have your interrupt of your GPU and your mouse on the same core, and a core that is not busy. And so that's why Proceess Lasso is very useful, is because we can specify which cores we want to do certain things. And so now that we've done that, once we click Set Mask and then set it, we will have to restart as well. Now that we've done that, the final thing that we can tweak is the IRQs. And the IRQs are the interrupt request queues. But the thing is that Windows sets a specific interrupt queue for all of the different devices in the system. And so Windows will just automatically default to whatever's in the queue number, essentially itself. And so we don't want that, because it can take too long because we might have too many interrupts for whatever reason. But if we go to this registry right here, and we can look for 2 different values. The first one is going to be the Windows 32 priority separation. Windows 32 priority separation is essentially the amount of time that each service is going to get. And so 2A means essentially spend 3 times as much time on the foreground process. So the game or the software that I'm using right in front of me. And the reason why this is really important is because if we specify the process that is on the foreground, it means that it has the highest chance of getting all of the information through and having the lowest input lag. And so that's why 2A, if you set this value to 2A, it'll feel extremely responsive, especially if you've given this a few different tries with different values. The best values are 16, 2A, I believe it's 7777, so 4 sevens, and those are the most popular ones. But regardless of that, for the interrupt request queues, if we go down into the System Information Device Service, and then we go down and we look for our GPU, we can see that our GPU is 4294967254. If we create a DWORD 32-bit value with that specific interrupt request queue, we can specify it to have a value of 1. 1 essentially is the highest priority interrupt. And so if the system has to do 3 or 4 different interrupts, whatever interrupt has the process priority of 1, will have the highest chance of being prioritized by Windows. And so that's what we want, is we want all of the parts of the system, the service, the buffer, the actual interrupt itself, the Windows priority of the buffers, and the Windows priority of the actual services. We essentially have controlled every part of the chain. And so that's the main things. Now, the final thing I will add, and this one is kind of 50-50, just depending on what you actually prefer, but inside of the Windows devices, there is a specific device, and it's called High Precision Event Timer. And so for you, it'll probably look like this. It'll be in the System Devices tab, and it will be within here. A lot of people disable this one because the High Precision Event Timer, it tries to time all of the different Windows services, but it fails horrifically because all of these services are way faster than what this program or this device was meant to do. There are a ton of videos online where disabling this will give you sometimes drastic input lag reduction or FPS gains at the minimum. It's just a service that causes lots of issues. And so what a lot of people will do is what they'll say inside of command prompt is bcd edit/set use platform clock no. And so if I go like that and I go into command prompt and run it as an administrator, and so I do bcd edit/set use platform clock. In fact, if I set that specific parameter, the way that I can verify it is if I do enum all, it will lay out all the information, and it will tell me specifically inside of the Windows bootloader what I'm specifically using. And so using platform tick, yes. Disable dynamic tick, yes, because dynamic tick is a power saving feature. And so that's the main thing here. And then the timer synthetic sync policy, we want to set that to enhanced. There are two other ones, which is default and legacy. Some people prefer one or the other. You can choose for yourself. But most people generally agree that platform tick is the most preferred for system responsiveness. And so that will help you also fix the set timer resolution, because timer resolution only works if when you click the maximum, it is running at 0.5, or if you click the default, it's running at 1. It can technically go higher, but it can't go any lower than those two specified values. And so yeah, guys, that's everything. We now have manipulated every single part of the system, and we have set everything to exactly what it needs to be. I hope you guys enjoyed this video. Please like and subscribe. Please favorite. Let me know if all of these tweaks have helped you guys out. Please, comment down below if you have any questions, concerns. I'd love to chat and respond to all of them. I hope this video has helped you understand more about your system and the way that it functions. My name is Csrss, and I'm out.